All right, welcome everyone. Ever wondered what goes on inside the mind of a self-driving AI? Well, today we're going to pop the hood and take a look. We're going to follow the entire journey, from a simple pixel on a screen all the way to a car making a turn. This is where we get to see the real magic, the dynamo of deep learning in action. Let's dive right in and see how a machine actually learns to drive.
So, it really boils down to this one huge question, right? How on earth does an AI learn something as complicated as driving just by watching? I mean, think about it. It doesn't know about physics, it doesn't know what a stop sign is, it just watches. The answer, though, is actually pretty cool, and believe it or not, kind of simple in its elegance.
Okay, so the core idea here is something called end-to-end imitation learning, and end-to-end is the key part. It literally means we're building a direct pipeline from the AI's eyes, the camera, straight to its hands, the steering wheel and pedals. So forget about writing millions of if-then rules, like if the light is red, then brake. No, we're just going to let the AI watch a pro driver and figure it out for itself. It's all about learning by copying.
So what's the big takeaway here? The AI's whole job is to build a kind of digital reflex. It's trying to create an instant gut reaction connection between what it sees and what it needs to do. It's not thinking in words or rules. It's learning to map that giant mess of pixels from the camera directly to two simple commands: how hard to press the accelerator and exactly where to point the steering wheel. It's that direct.
And this whole process, it's actually a pretty elegant loop. First, you have the expert human driver just driving. And while they do that, the system is like the world's most diligent student, just taking notes. It's recording every single frame from the camera and matching it with exactly what the driver did with the steering and throttle. Then, the AI just pores over all that data, looking for patterns, making connections, until it feels confident enough to say, okay, I think I get it, let me try. But before it can drive, it has to see. So let's talk about the AI's eyes.
All right, so let's get into the nitty-gritty. We're at the first stage of the AI's thought process, its eyes. And this is where a really clever piece of tech comes into play. It's called a Convolutional Neural Network, or CNN for short. You can think of it as the AI's visual cortex. Its one and only job is to take that absolute chaos of raw data streaming in from the camera and somehow, some way, find meaning in it.
And when I say a flood of data, I am not kidding. For every single frame, and remember, there are many frames per second, the AI gets hit with a 224 by 224 pixel image. Now, if you multiply that out and account for the 3 color channels, red, green, and blue for each pixel, that's more than 150,000 separate data points, 150,000 numbers it has to crunch instantly for just one moment in time. So, how in the world does it not just crash?
Well, it has this brilliant 4-step thinking process. It's almost like a detective looking at a crime scene. First, it uses something called convolution to scan for clues, the real basic stuff like lines, edges, corners, and different textures. Then, ReLU acts like a filter, telling it to focus only on the important clues and ignore all the background noise. After that, batch norm makes sure it's not getting fixated on any single clue, kind of normalizing its perspective so everything gets a fair look. And finally, pulling steps back and summarizes the whole scene, putting all the clues together to get the big picture. And this is where it gets absolutely mind-blowing. After all of that scanning and filtering and summarizing, that mountain of over 150,000 pixel values gets crushed down into just 256 numbers. That's it, 256 key features. This is the pure essence of what the AI sees. It's no longer thinking about pixels. It's thinking in concepts, like the road is curving left, or there's a car-shaped thing up ahead, or I'm getting close to the white line. That's perception.
Okay, so the AI can see now. It's turned a picture into a set of meaningful features. So what's next? Well, we move from the eyes to the brain. This is a part called the Multi-Layer Perceptron, or MLP. You can think of this as the central command, the decision-making hub. This is where those 256 features from the eyes get put to use to actually do something.
And here's what makes this so smart. The AI isn't just a robot staring at the road. It's also self-aware, in a way. It's taking two completely different streams of thought and merging them. On one hand, you have the features from the CNN, which basically answer the question, what's happening out there? But on the other hand, it's also checking its own battery level, which answers the question, how am I doing in here? What's my energy level? Combining those two things, that's how you get truly intelligent, context-aware decisions. Now, while it's learning, the AI does something really fascinating to make itself smarter. It's a technique called dropout, and it's kind of like forcing itself to train with a handicap. It will randomly just ignore some of its own neurons, some of its own internal connections. Why? Well, it forces the AI to find multiple ways to solve a problem, so it doesn't get lazy and rely on just one single trick. It stops it from becoming a one-trick pony and turns it into a much more flexible and resilient driver.
So let's recap. We've got this incredibly complex process, right? We're analyzing a massive image. We're distilling it into key features. We're checking our own internal battery status. We're even randomly shutting down parts of our own brain to get tougher. And after all of that, what's the final output? How many complex commands does it need to send? Well, it's just 2.
And that right there is the absolute beauty of an end-to-end system. You take this massive ocean of input data, more than 150,000 numbers from the camera, plus that one little number for the battery, and you funnel it all through this incredible network, and out the other side comes just 2 clean, simple numbers, one for torque and one for steering. All that complexity, all that perception is instantly translated into direct physical action. It's incredible.
Okay, but hold on a second. There's a potential problem here, right? What happens if the AI gets into a situation that the human driver never encountered? What if it makes a small mistake and ends up somewhere weird? If it only knows how to copy, it's going to be lost. This is where the whole learning process has to evolve. It needs to stop just copying and start learning from its own experience.
Because here's the hard truth. Just copying the expert isn't enough to make a good driver. Sooner or later, the AI is going to mess up. It's going to swerve a little or take a corner too wide, and suddenly it's in a situation it's never seen in the training data. And if all it knows is what the human did, well, it's stuck. It has no idea how to get back on track. It needs to learn how to recover from its own mistakes.
And the solution for this is a really powerful feedback loop called DAGGER. It stands for Dataset Aggregation. And here's how it works. Step 1, you train the AI on the original human data, just like before. But then, step 2, you let the AI go out and drive for real, and you collect all the data from its drive, paying special attention to the moments it gets confused or makes a mistake. Step 3, you take all that new data and add it to the original human data. And finally, step 4, you retrain the whole model on this new, bigger, better dataset. It's a cycle of practice, learn, repeat.
And that is the giant leap. That's the moment the AI graduates. It goes from being a parrot, just mimicking what it saw, to becoming a truly adaptable, intelligent driver. It's not just repeating the past anymore. It's actively going out, finding its own weaknesses, and learning how to solve new problems all by itself. So, let's just quickly pull all that together. What have we seen? We've seen an AI that learns by watching, using imitation learning. We've seen how it sees the world by using a CNN to turn a flood of pixels into a handful of key features. We've seen how its brain, the MLP, makes decisions by mixing what it sees outside with what it knows about itself on the inside. And crucially, we've seen how it gets smarter, how it improves by learning from its own real-world experience, using that DAGGER cycle. And so, that leaves us with one last really big question to chew on. This incredible cycle, watch, do, learn from your mistakes, it's powerful enough to teach a machine how to drive a car. So what's next? If an AI can learn a skill this complex just by experiencing the world, what other things could it master? Think about it. Complex surgery, discovering new scientific principles. What's the next great human skill that's going to be mastered by an AI that learns all on its own?